Okay, so we're back looking at this museum curator moving the statue across the table again. Okay, except this time we're looking at part B. Once the sculpture is moving, it takes a force of 670 newtons to keep it moving at a constant velocity. That is some keyword and key information for us. What is the coefficient of kinetic friction between aluminum and steel? So go back and let's quickly look at equilibrium. It says all the forces cancel each other out. The forces up balance the forces that are down. There is no acceleration at rest or moving at a constant velocity. That means this is an equilibrium problem. Okay, so we're going to solve it like an equilibrium problem. Let's go ahead and look at our force tips. Step 1, draw a free body diagram. So I'm going to go ahead. F of G is almost always present. If there's a surface, then we've got a normal force. So I'm going to go ahead and do those pretty quick. Gravitational force, because we are near Earth's surface, and the normal force, because it says the surface is horizontal, therefore the normal force is going to be perpendicular to horizontal, or vertical in this case. And then there is a surface, so there's going to be some sort of friction. So let's say we're applying a force to the right, therefore the friction will be to the left. In this case, the object is moving at a constant velocity, but it is moving. So moving means that it is going to be kinetic friction. Okay? And we are applying a force to the right then. So that is going to be our applied force. Okay? If we go back and look, we can see there's no string here. Okay? And we've got the applied force. So we're good there. Step 2, write down your givens. Well, it's a 145 kilogram aluminum sculpture, so the mass is 145 kilograms. And it says our force that we are applying is 670 newtons. So the applied force is 670 newtons. Okay, so we've got our picture, we've got our givens. Next step, write down what we're trying to find. The coefficient of kinetic friction. That is mu sub k, the coefficient of kinetic friction. So that's what we're trying to find. Next step, write down some equations. A hint, are you in equilibrium? Yes, we're moving at a constant velocity. Therefore, we are in equilibrium. So we've got these equations. The net force in the x direction is 0. The net force in the y direction is 0. So let's write those down. The net force in the x direction is equal to 0. The net force in the y direction is equal to 0. Okay, now let's go ahead and see what we can get from that. The net force means add up all the forces in the x direction. I see 2 forces in the x direction. F sub k is pointing to the left, so I make that negative. The applied force is pointing to the right, so I'll leave that positive. Add them together. They add up to 0. Well, I've got the applied force right here. I can substitute it in. So the opposite of the force of kinetic friction plus 670 is equal to 0. Add force of kinetic friction to both sides, and we get force of kinetic friction is 670 newtons. Okay, and we're going to go ahead and take a look at our y direction. In the y direction, there are 2 forces. The gravitational force acting in the downward direction, so I make it negative, plus the normal force acting in the upward direction, so we'll leave it positive, and they add up to 0. Gravitational force, not written down over there, okay? So we have to find it. Well, we know the gravitational force is equal to the mass times the gravitational field constant. So gravitational force is equal to 145 times 9.81. The gravitational force is 1,422 and 4/500 newtons, just like it was when we were in part A. Okay, so now we can substitute that in over here. So it's in the downward direction, we make it negative 1,422 and 4/500. Plus the normal force is equal to 0. Add 1,422 and 4/500 to both sides. And we have our normal force. Excellent. Okay, we're trying to find the coefficient of kinetic friction, so we have to find an equation that has the coefficient of kinetic friction in it. The force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. We have both of these variables now, so we can go ahead, substitute them in. So 670 is equal to the coefficient of kinetic friction multiplied by our normal force, 1,422 and 45 hundredths. Divide both sides by 1,422 and 45 hundredths. And we will get the coefficient of kinetic friction is 0.47. Again, this coefficient does not have any units either. We had newtons, we divided by newtons. Okay, it's a coefficient, it does not have any units.